What is an IP address in network traffic analysis? Imagine trying to find your friend's house in a huge city without an address. It would be nearly impossible. In the world of networks, an IP address acts like that address, guiding data to the right place. When we analyze network traffic, understanding what an IP address is becomes essential. It is a unique number assigned to each device connected to a network using the Internet Protocol. Think of it as a device's digital home address. Every time data moves across the Internet, it carries this address, telling us where it comes from and where it is going. This helps network managers and security teams keep track of all the activity happening on their systems. Each data packet sent over a network contains two main IP addresses, one for the sender and one for the receiver. This information helps us see the flow of data, like a map showing where information originates and ends. By examining these addresses, analysts can spot unusual patterns, such as unexpected connections or traffic from suspicious sources. This is especially useful for detecting cyber threats or unauthorized access. It also helps troubleshoot problems by pinpointing where issues might be happening. An IP address has two parts. The first part identifies the broader network, called the network identifier. The second part identifies the specific device within that network, called the host identifier. This structure allows routers to figure out the best path to send data, whether within local networks or across the Internet. There are two main types of IP addresses in use today. The first is called Internet Protocol version 4, which uses 32-bit numbers. These are written in for groups of numbers separated by dots, like 190.160.1.1. They provide about 4 billion addresses, but with so many devices connecting, these are running out. The second type is Internet Protocol version 6, which uses 128-bit numbers written in hexadecimal separated by colons. These addresses are much longer and can support a vastly larger number of devices. Many networks use private IP addresses internally, which are not visible outside the network. To access the Internet, these private addresses are translated into a single public IP address through a process called network address translation. This process masks internal device addresses, making traffic analysis more complex but also more secure. In network traffic analysis, IP addresses are key tools. They help identify which devices are communicating and monitor the flow of data between them. This allows security teams to spot unusual activity, such as connections to known malicious IPs. It also helps in troubleshooting by tracing the source of network issues. Additionally, logging IP addresses supports compliance and auditing efforts, ensuring organizations meet security standards. Understanding IP addresses is fundamental for managing and securing networks. They serve as the digital identifiers that keep data moving smoothly and safely across complex systems. Whether analyzing traffic at content delivery networks, internet exchange points, or data centers, knowing how IP addresses work helps us see the bigger picture of how information travels through the Internet.